Hello, this is Yusuf. I have seen a lot of people asking questions about how to debug stuff that they have seen in extended Kalman filter project by the Udacity in self-driving car Nanodegree. They got a lot of errors regarding the matrix operations, matrix initializations, and they don't know where are they coming from, and they need to do a lot of like hard debugging and to find out what is it, doing a lot of prints or see where they can find some sort of finding the bug, exactly where is the bug coming from, and the message that is coming out of the executable is not that much readable. So in this tutorial I'm going to teach some sort of method to debug the codes easier. My goal is to use the Visual Studio Code as IDE, and we use the Visual Studio Code debugger stuff. So for Visual Studio, we're starting from just installing the Visual Studio by like this, sudo apt install code. I have already have it installed, or you can just follow the instruction in the official Visual Studio Code web page for the Linux. I am running on Ubuntu 18.04. Yeah. So when we get the Visual Studio, currently, then we just like clone the starter kit, starter code from the Udacity repo, git clone like that. It just makes that folder. Then we just go to that folder and then make dir. We make a build directory to just put all the compile files and the executable inside the build directory. Okay, now we are inside the project folder. We just say code dot. It just runs the. It just opens up the Visual Studio Code in that folder. Now we need to set up the Visual Studio Code first for C++ stuff, and then the compiling, and then the debugging. To install the C++ extensions for the Visual Studio, you just click on this extensions tab. Here, search for C++. You need to be connected to internet, of course, and then click this. I have already installed it, so instead of these buttons, you will see install button right like this. So you should need to install the C++ extension from Microsoft. So this is the main step you get from that. Okay, and then usually after installing that, you need to close the Visual Studio Code IDE and then open it again. So let's go back to the folder. Now we need to set up the compiling and like also the CMake stuff to generate the make files. To do that, of course, we need also some sort of GCC version. Currently, I have GCC version 7.3 on my machine. So if you don't have, you can just install it using sudo apt install GCC .-7 or 6 or whatever version you need. Okay, let's make the settings for the Visual Studio for the C++. To make stuff and also to do the CMake, we need to define some tasks. That these tasks are going to be a kind of task.json file in Visual Studio Code. To do that, just hit Ctrl-Shift-P, this guy here, Ctrl-Shift-P, and say I need to configure task. So let's say task, and then find this configure task, create task.json from template and others. So it just creates a template file which is empty. We replace the whole this with that one. What we did here, we defined two tasks. One is called CMake and the other one is just build all. The CMake is just run the CMake commands that you need to generate the make files, and the so it says the current working directory is in the workspace root and in the build here. Of course, you need to save this file, and then sorry, it's run the CMake with these arguments. And this part is very important. We should set the CMake build type to debug because we want to later debug. And there is another task it's called build all. So first let's run this task, and to show you, so the build directory is empty. So I hit again Ctrl+Shift+P and say run task. Okay. Run, let's say tasks. I don't know why it doesn't shows up. Tasks, run task, and then we need to choose which one. We define CMake and build all. We want now first CMake, and then continue without scanning. So it just generated the CMake files that we needed, and also the make file. And now we need to compile everything. So again, Ctrl+Shift+P, and then task, run task, and then build all. So it compiles it. Actually, because we set it up to be a default compile stuff here, we said that it's a kind from the build and it's true. We can just compile with Ctrl+Shift+B. It does again the compiling. Okay, we have it now compiled. It generated the executable file here. Now we need to set up the debugger. For debugging stuff, we need something called launch.json file. Actually, these task files and all these files are going into the .vs code folder in the workspace. To set up the launch.json, we just again Ctrl+Shift+P. We just search for launch. It just opens debug, open launch.json. And then we are doing C++, and it just create us an empty a template one that we just need to change one field here. So let me, which is the program. It's a pass to the program. We just need to pass it to this extended file. So we just need to remove this guy, and then just rename this dash this a.out with our file. So this is almost done. So what does it mean, the debugger? That means that we can make, for example, if I just open the main, the source, my main.cpp, that means I can make a breakpoint here and stop my code somewhere in the code. So I just hit, by clicking here, I created a breakpoint, and then I'm going to the debug window. So this launch.json file, the name of the debug configuration is gdb launch, and this is appearing here again. So I just click on this and then hit green button. Okay, something is wrong. It cannot find the extended command file. Oh, sorry, I just did a mistake here. I need the build. It's in the workspace in this folder, and then build, and then extended command. So that should work now. So it just, yeah, it's working. So it's open the terminal. If you do some printing or see out thing, and then if you see the code stopped here, and now you have this tool here. So this is like continue running it. This is just stepping over this line. This is going into that. So for example, let's do that. So we went into that constructor of the Fusion EKF. And just go line by line and see what's going on. And what does it mean to see going what's going on? We just see the, for example, here we need the local variable. We can see the local variable and also a variable for this object. So, for example, I just stop. Let me introduce some errors. For example, I set up the R laser laser to a matrix of a 2 by 2 matrix, but I initialize it only the 2 first. Okay, so if I run it, for example outside, just need to go to the build and just say dash extended, right? Oh, sorry, I forgot to compile it. First compile it. So it compile, and then I run it. So I get some bad errors here that it's not easy to understand. Where is it coming from? Which line of a code is, and these sort of thing. So, but using the debugger, I do not use any breakpoint, and just say okay, debug. It opens up. It gives me. It cannot open some file. It doesn't matter right now, but it's just giving me a call stack here. What happened during that debug? So it happened here that it's being called. I mean, it's the chain of where is it coming from, the error. So it's from the main. In this line of a main it happened, and then you can go inside of it, and it says here it's something here. Now I have some ideas that the error is based off this here, so I can check. Okay, this our laser was like 2 by 2 matrix, but it's initialized at just by 2 term. So I know that the error is coming from here, and I can somehow correct it because these codes are from eigen libraries, so I haven't written those stuff. So I do not expect that the error is coming from here. So it's here. I just stop this and just correct it. Like, what was it? It was like 0 and the same value. Save it, and again compile it, and now I know it's at least I reached that listening or something. And also you can also put a breakpoint somewhere else, like inside the process measurement. So I want to check something here. I just put a breakpoint, and then I run the simulator. I run the simulator with some ID. So it's this and start. So it just went one step, and it just caught by this breakpoint. So it's just waiting here. You can check your variables. Currently the variables, they don't look good. You see here you don't understand a lot of stuff. There are some techniques to make them like good. So I will start to describe those stuff. So for now I will stop this. I close this. Okay, I wanted to close this as well. Okay, to make these beautiful, I mean the debuggers, it's pretty interesting. I don't know why it's working, but it's like that. So you need to make some debug folders. I mean any folder somewhere. I just put it in like here, one folder above this, but you can put it anywhere you want. So the name doesn't matter, nothing. Just created the debug folder, and then we need to download these files from the eigen library. Okay, and then so we need to open this printers.py in any library. So here in the printers.py it just says how to use it in the beginning. So it says create a gdb init the file. So let me open that file as well with gedit. So it seems that some other softwares has generated this for me, but we need if you have this file empty, it's okay. If you have empty, you just copy all these stuff into it, but for me I just need to add the missing part. So I'm just missing this part, and I need to update this pass to the pass that I have to this pass. That has this printers and this stuff. And then I need this one here, and then I need this, and then the rest exit. I just save it, Control S, exit it, and just go. Another thing is that according to this guy here that I have a link, this file is written printers.py for Python 2, which my system just supports Python 3, so I'm using this software to transfer it. Here it commands that to use this software to transfer the Python 3 to Python 2. So I'm just installing this one, it's already installed for me, and then 2 to 3 and then the Python name, and now I have this file as Python 3. Okay, now everything should be good. So if I I will make a breakpoint here as well. If I run the debugger, now if you see all the icon stuff, instead of some difficult to read stuff, it's just coming out as like 0.0, the value 1.0, and you can now see the content of the matrix. And we had this here as well, for example. Let me put it after that, and if I just hit continue, so it's just waiting for the simulator. Let me run the simulator. Oops, what happened? That's bad. Okay, now if I run it, it's gonna stop here, and here in my this I was checking, for example, X, EKF, and the X is just 0, 1, 2, and it's very nice. So you can read all the variables, matrix, the content of each matrix here in this window. And also you have that call stack here, why we are stopping here, paused on a breakpoint, and this sort of stuff. So you can go line by line what's happening here, what you are doing, and also if you have any wrong matrix multiplication, matrix initialization, in this way you can get it exactly where it's happening, and you can like easily debug it easier. I mean, it's a lot of work to do that here, but yeah, that is much better and easier. Great, thank you, and enjoy learning. Bye.